The supposed comet is catching the attention of some of the nation's most renowned scientists, as one Harvard professor is raising the theory this may actually be a piece of alien technology.
A mystery interstellar object that was spotted by astronomers last week. It could be the oldest comet ever seen.
The newest image of 3I/Atlas has caused a stir in the scientific community because it challenges assumptions that seemed solid only months ago. When the discovery of this interstellar visitor was first announced, astronomers were already prepared to add it to the small but fascinating group of objects known to come from beyond our solar system. Yet the latest data captured and released reveals features so unusual that even seasoned researchers are struggling to categorize them. Instead of offering clarity, the image has widened the mystery of what 3I/Atlas actually is and why it looks the way it does. Before we start, smash the like and subscribe buttons for more updates. From the outset, 3I/Atlas distinguished itself by its path through the solar system. Its orbit could not be explained by any gravitational interaction within the planets or the Kuiper belt, and calculations confirmed it must have originated far outside the sun's sphere of influence. This alone made it worth extraordinary scrutiny, since interstellar objects act as messengers from regions of the galaxy we cannot reach. The release of its newest high-resolution image has given astronomers a closer look at its form, but rather than a familiar comet-like body, the image shows something entirely different. The brightness variations, structure, and even the apparent surface composition seem inconsistent with expectations. Part of what makes the release so striking is the contrast between 3I/Atlas and its predecessors. Oumuamua, the first interstellar visitor detected, was itself an enigma, too oddly shaped and too reflective to match typical cometary bodies. 2I/Borisov, on the other hand, fit more closely with standard cometary models, shedding gas and dust in predictable ways. 3I/Atlas, however, appears to occupy a category all its own. The latest image reveals irregular light scattering and surface activity that do not match either the comet-like profile of Borisov or the elongated tumbling body of Oumuamua. Instead, it seems to hint at some hybrid state, half active and half inert, defying any neat classification. What astonishes astronomers most is the strange luminosity pattern visible in the image. Normally, the brightness of an object like this can be traced to sunlight reflecting off ice, rock, or a dust coma. But 3I/Atlas shows zones of brightness that appear asymmetric and uncorrelated with its position relative to the sun. This suggests either a highly unusual surface texture or an interaction between solar radiation and material that behaves unlike anything yet cataloged. Some researchers speculate about volatile compounds that have not been observed in local comets, while others wonder if surface fractures could be exposing layers of material that erupt in unpredictable bursts. The image clearly shows bright streaks offset from the expected coma, raising more questions than answers. The broader implications of this are profound. If 3I/Atlas carries material foreign to our solar system, then studying it could give scientists their first direct sample, albeit at a distance, of the chemistry of another star's planet-forming disk. The latest image suggests that standard models of cometary evolution cannot fully explain interstellar visitors, and that the galactic neighborhood may be far more diverse in its small body population than we ever realized. Each new observation points to the possibility that what we have seen in our solar system is only a tiny fraction of the potential planetary debris sculpted by other stars. This diversity challenges theories of how planetary systems develop and how stable their remnants are over cosmic time. Even more compelling is what the image implies about interstellar travel of such bodies. To reach us, 3I/Atlas had to wander through space for perhaps millions of years, surviving radiation, collisions, and the emptiness of interstellar voids. The image highlights an oddly intact structure, suggesting resilience to conditions that might have shattered or eroded other bodies. This resilience in itself could be telling us something new about the mechanical properties of objects formed outside our system. Whether composed of dense refractory material or held together by some unknown mechanism, 3I/Atlas is not behaving like a fragile snowball of ice and dust. Instead, it is enduring, and in doing so, it is rewriting our assumptions about what can drift between the stars. The scientific excitement over the new release is amplified by the rarity of such opportunities. Detecting interstellar objects is extremely difficult. They are small, dim, and move rapidly through the sky. The fact that 3I/Atlas was captured in such detail at all is a triumph of coordinated telescope networks and image processing technology. Observatories worldwide had to act quickly, pooling resources and schedules to maximize observation windows. The success of this endeavor not only produced the remarkable image, but also demonstrated that humanity is becoming more capable of responding to fleeting cosmic events. Every photon of light gathered from 3I/Atlas now feeds into models that could prepare us for future discoveries. The puzzle of its unexplained image also raises intriguing possibilities for future exploration. If our telescopic instruments can barely make sense of its surface activity, then perhaps the next step must involve more ambitious missions. Discussions are already underway about the feasibility of intercepting an interstellar object with a dedicated spacecraft. The urgency is highlighted by what the 3I/Atlas image reveals: anomalies that cannot be explained without close-range investigation. To see fractured jets, strange reflectivity, or mysterious structural patterns is one thing, but to analyze their composition in situ would transform our understanding not just of one object, but of the galaxy's evolutionary history. There is also a cultural dimension to the release of the image. Whenever humanity encounters something profoundly new, it reshapes imagination as well as science. The first picture of Earth from space changed how we viewed our planet, while the first images of distant galaxies redefined our place in the cosmos. In a similar way, the 3I/Atlas image has the potential to become iconic, symbolizing not just a scientific puzzle, but the broader reality that our solar system is not isolated. Material drifts between stars, carrying with it the secrets of alien formation processes, and sometimes that material comes close enough for us to witness directly. The photograph is more than just data. It is a reminder of cosmic connection. The unusual aspects captured in the image also hint at the possibility that our models of interstellar medium interaction are incomplete. When a body like 3I/Atlas travels through space for millennia, it encounters charged particles, dust clouds, and radiation fields that can alter its structure. The surface anomalies now visible may be the scars of such encounters, fossilized records of a journey through galactic space. Scientists looking at the image see not only an object, but also a timeline encoded in shape and brightness, a natural archive of astrophysical conditions spread across vast distances. Unlocking those records could provide insights into regions of the galaxy that remain otherwise inaccessible. Of particular note in the released image is the irregular coloration across the surface. Some regions appear unusually dark, absorbing light in a way inconsistent with typical icy bodies. Others gleam with a reflectivity approaching metallic sheen. This juxtaposition has fueled speculation about compositional layering or even exotic mineral deposit. If verified, these materials would represent building blocks that originated under conditions very different from those of our solar nebula. The possibility that interstellar space is seeded with such diverse fragments opens up exciting prospects for comparative planetology, allowing us to place Earth and its neighbors in a much broader galactic context. The reaction among scientists to the image has been both exhilaration and humility. Each new piece of data on 3I/Atlas seems to remind researchers how little is truly known about interstellar wanderers. Theories can be proposed about volatile chemistry, about radiation scars, about structural resilience, but the image itself remains a stubbornly ambiguous piece of evidence, and in that ambiguity lies its power. It forces inquiry, demands new hypotheses, and resists easy categorization. It is in many ways the perfect scientific puzzle, one that will energize planetary science and astrophysics for years to come. Public fascination has also been stoked by the release. People outside the scientific community are captivated by the idea of something from another star system passing through our own, and an image brings that abstract concept into tangible reality. The strangeness of its appearance only enhances the sense of wonder. Here is an object that does not conform to what textbooks teach about comets or asteroids. Here is a visitor that challenges human understanding and invites speculation about the diversity of worlds scattered across the galaxy. The cultural resonance of such an image cannot be understated because it bridges the gap between cold data and lived imagination. What the latest image ultimately demonstrates is that the universe is more varied than we often allow ourselves to believe. The objects that drift between stars carry with them signatures of unknown processes, untouched by our familiar environment. 3I/Atlas is not just a curiosity, but a signpost pointing toward the vastness of galactic diversity. Its defiance of explanation does not signal a failure of science, but rather a triumph of discovery, a reminder that nature always has the capacity to surprise us. The released image captures more than an object. It captures the mystery of exploration itself. The excitement surrounding 3I/Atlas has sparked new questions about the frequency of interstellar bodies. If we have now detected 3 in just a few years, is it possible that they are far more common than once believed? The image suggests not just a singular anomaly, but perhaps the beginning of a pattern. Perhaps our galaxy is teeming with such fragments, and we are only just beginning to tune our instruments finely enough to notice them. If so, then 3I/Atlas will not remain a solitary puzzle, but part of a growing dataset that could reshape planetary science. The story of this image is not confined to one research paper or one press release. It is part of a larger arc in which astronomy moves from speculation to observation, from models to real data. Each strange detail visible in the released photo is a challenge to refine our understanding of how matter forms, travels, and evolves in the galaxy. The streaks, the reflectivity, the unexpected patterns, these are not mere anomalies, but clues in a grand investigation. Scientists are already reworking their simulations, rethinking assumptions, and preparing new instruments to be ready for the next visitor. The release of the new 3I/Atlas image stands as a milestone in the story of human curiosity. It shows us that the cosmos remains a frontier full of riddles. It demonstrates that even with the most advanced telescopes and analytical tools, the universe still holds back secrets, offering only tantalizing glimpses. The image is a window into the unknown, both scientifically and philosophically. It embodies the thrill of encountering something that cannot yet be explained, a reminder that knowledge is always provisional, always expanding, always reaching toward greater depths. And so, the significance of the new 3I/Atlas image is not just in what it shows, but in what it represents. It is proof that discovery is ongoing, that the galaxy is alive with motion and surprise, and that we are fortunate enough to witness some of its mysteries firsthand. The unexplained features in the image are not a limitation, but an invitation to question, to investigate, and to wonder. For scientists and the public alike, the message is clear. The story of interstellar exploration has only just begun, and 3I/Atlas is its latest, most enigmatic chapter. The newest 3I/Atlas image, with its startling revelations and mysterious features, is already being described as one of the most enigmatic astronomical releases of the decade. Yet while the initial discussions have focused on its odd luminosity, structural peculiarities, and apparent resistance to conventional classification, the deeper significance lies in the avenues it opens for science and the questions it forces us to confront. Beyond the first impressions, the image represents a crossroads for multiple fields of research, ranging from astrophysics to planetary geology, from chemistry to cosmology. It is a single photograph that has cascaded into 1,000 debates. One of the most intriguing areas of focus stemming from this new release concerns the possible formation environment of 3I/Atlas. Most comets and small bodies in our solar system are thought to have originated in regions like the Oort cloud or Kuiper belt, shaped in the early epochs of planetary formation. For an interstellar object, the formation environment could have been vastly different. The image suggests surface features that appear irregular and layered, almost as if they were deposited in multiple stages. This layering effect hints at an object born in a dynamically active environment, perhaps near the edges of a protoplanetary disk, where gravitational instability, collisions, and stellar winds would have contributed to unusual compositions. The idea that the image captures, frozen in time, the processes of an alien star's formative years is staggering. Every visible ridge or luminous anomaly could encode an origin story from a stellar nursery beyond human reach. The structural strangeness visible in the image also opens a debate about the role of gravitational ejection. Objects like 3I/Atlas are believed to have been expelled from their home systems by gravitational interactions with giant planets, or through the chaotic dance of close stellar encounters. The new photograph reveals an object that does not resemble the fragile, ice-dominated debris one might expect to be tossed into interstellar space. Instead, it suggests resilience. Could it be that planetary systems across the galaxy preferentially eject their toughest, most unusual fragments? If so, interstellar space might be filled not with fragile comets but with bizarre hybrids like 3I/Atlas, rare survivors that can endure cosmic wandering for millions of years. The image gives weight to this hypothesis, since every scar and luminous anomaly seems to confirm the idea of survival against impossible odds. From the perspective of chemistry, the image is equally provocative. Unusual reflectivity patterns hint at the presence of materials unfamiliar to our catalog of solar system bodies. Some researchers suggest that what we are seeing might be the spectral fingerprints of exotic ices, compounds such as nitrogen-rich clathrates, ammonia hydrates, or even complex organics that never had the chance to evolve in the relative stability of our solar nebula. The possibility that 3I/Atlas contains alien chemical structures has profound implications for astrobiology. If organic-rich bodies can be ejected from their systems and survive long journeys, then the galaxy may be littered with vehicles for organic distribution, seeding potential precursors of life wherever they pass. The new image does not confirm this directly, but it strongly fuels the idea by refusing to match any known chemical profile. Equally fascinating is how the image challenges our understanding of surface dynamics. The asymmetric streaks of light observed do not align neatly with solar illumination, which means processes other than simple reflection are at play. One possibility is that internal pressure from volatile materials is releasing jets in unpredictable ways. Another possibility is that magnetic or electrostatic interactions are producing surface phenomena unfamiliar in local comets. Some theorists have even suggested that 3I/Atlas might be wrapped in a sheath of charged dust particles, a kind of microcosmic plasma interaction that gives it a unique glow. If true, then the image may be our first observational glimpse into a whole category of interstellar plasma interactions that standard comet science has overlooked. The mechanics of its motion add another dimension to the mystery. While orbital calculations confirm its interstellar trajectory, the new image, with its enhanced resolution, has allowed scientists to refine measurements of its rotation. What they have discovered is unexpected. A complex tumbling spin that appears inconsistent with the symmetrical outgassing typical of solar system comets. Instead, the spin pattern suggests either an irregular mass distribution or a recent alteration of momentum, perhaps caused by asymmetric jets erupting from beneath the surface. If such activity is confirmed, it means 3I/Atlas is not a passive traveler, but an active, evolving body that continues to surprise with every observation. This release has also forced cosmologists to reconsider the statistics of interstellar objects. For decades, models predicted that countless fragments should drift between stars. Yet it was only in recent years that our instruments grew sensitive enough to confirm them. The fact that the third such object presents anomalies as striking as those revealed in the image suggests that diversity may be the rule, not the exception. If 3I/Atlas is representative of what lies beyond, then the galaxy may be filled with bodies so varied that our current classification schemes will have to be expanded dramatically. The photograph, in its strange glow and fractured surface, is a call to humility. We know only a sliver of what exists. There is also an observational triumph embedded in the image's release. Capturing such a fleeting object at this resolution required extraordinary coordination. Ground-based telescopes had to align their schedules, adaptive optics had to push the boundaries of atmospheric correction, and space-based observatories contributed their high-clarity vantage points. The resulting composite is a technological feat that highlights humanity's growing ability to respond to transient cosmic events. This is not just an image of 3I/Atlas, it is a portrait of our evolving scientific infrastructure, proof that we are building the capacity to study the unpredictable universe in real time. Speculation has naturally spilled into the realm of what lies ahead. If the image reveals mysteries beyond explanation, then perhaps the only way forward is direct engagement. Ideas for intercept missions, once theoretical, now feel urgent. Concepts for high-speed spacecraft that could rendezvous with interstellar visitors are gaining renewed attention. A mission to a body like 3I/Atlas would be unprecedented, offering the chance to analyze alien materials directly and test whether the anomalies observed in the image represent chemistry, geology, or entirely new physics. The excitement generated by the photograph is likely to accelerate momentum toward such endeavors. The broader scientific community sees this release as an opportunity to connect discipline. Geologists are weighing in on the surface patterns. Chemists are analyzing potential compositions, and astrophysicists are refining models of interstellar trajectories. The sheer strangeness of the image demands cross-disciplinary collaboration, because no single field can fully account for the evidence. In many ways, 3I/Atlas has become a catalyst for scientific unity, drawing together researchers across specialties in pursuit of a shared enigma. For all the technical details, there is also an undeniable sense of wonder that comes with the image. Humanity has always been captivated by the unknown, and few things symbolize the unknown more vividly than a traveler from another star system. To see it not as a blur but as a distinct textured luminous body is to experience the thrill of contact with the beyond. The photograph is not simply data for specialists, it is a cultural artifact, a reminder that the universe is alive with surprises waiting to be noticed. Philosophers and thinkers outside the sciences have also been quick to interpret its significance. To some, the image is a reminder of the limits of human knowledge, a humbling illustration that even with our best instruments, the cosmos retains secrets. To others, it is a symbol of possibility, the idea that if alien chemistry and structures exist, then the seeds of life may be scattered far more widely than once imagined. The photograph of 3I/Atlas resonates beyond the laboratory, speaking to timeless human questions about our place in the universe. What stands out most, perhaps, is the sense of contradiction embodied in the image. It is simultaneously a fragment of rock and ice and a messenger of the infinite. It is a small, finite object, and yet a representative of the vast unknown. It resists explanation, and in doing so, it expands the boundaries of thought. Every unresolved question raised by the image, about chemistry, about formation, about resilience, adds to its power. The photograph is not merely a scientific puzzle, but an emblem of the ever-expanding horizon of knowledge. This sense of contradiction extends to the very act of observation. On the one hand, the image has brought 3I/Atlas closer than ever before, allowing us to see its surface in unprecedented detail. On the other, it has reminded us of how distant it remains, an unreachable traveler moving too quickly for any current spacecraft to catch. The photograph is both intimacy and remoteness, a paradox that mirrors the dual nature of science itself, to know more while realizing how much remains unknown. The release of the 3I/Atlas image is therefore more than just an astronomical event. It is a convergence of science, philosophy, culture, and imagination. It underscores the power of curiosity and the unpredictability of discovery. It demonstrates that the cosmos is not a static backdrop, but an active, dynamic stage filled with visitors who carry messages from realms we cannot yet touch. The photograph is a reminder that the frontier is not closed. It is passing through our skies, leaving behind light, mystery, and inspiration. Even as scientists debate the technical details of the image, they are united in their recognition of its significance. It is a rare gift to capture something so unexplainable, so unexpected, and so full of implications. The photograph of 3I/Atlas may defy explanation, but in doing so, it fulfills one of the deepest purposes of science, to provoke questions that reach beyond current limits. Each luminous streak, each irregular shadow, each inexplicable glow is an invitation to explore further. And perhaps that is the true legacy of this image, not the answers it withholds, but the questions it compels us to ask. The release of the new 3I/Atlas image has done more than spark debate in scientific circles. It has forced a re-evaluation of humanity's ability to conceptualize objects that fall entirely outside of familiar frameworks. Up until now, astronomers could, with some confidence, categorize nearly every body they encountered as a comet, asteroid, dwarf planet, or fragment of planetary debris. But the strange irregularities revealed in the photograph break these molds. What we are witnessing may well be the first clear sign that our classifications are too narrow, constructed only from what has been observed in the solar system rather than what exists across the galaxy at large. This notion leads to an essential consideration. Perhaps categories like comet and asteroid are parochial, meaningful only within the limited sample space of our own neighborhood. If the galaxy teems with objects that formed under vastly different chemical conditions and environmental pressures, then 3I/Atlas is evidence that our solar system is not a standard template, but one among countless variations. The photograph becomes a kind of mirror, reflecting back the limitations of our imagination. In forcing us to see something unclassifiable, it challenges us to expand our conceptual toolkit and develop entirely new taxonomies that can account for the richness of interstellar diversity. The educational implications are just as profound. For decades, textbooks have described small bodies of the solar system in neat diagrams, showing spherical asteroids, dusty comets, and icy nuclei surrounded by glowing comae. The image of 3I/Atlas disrupts this tidy narrative. Future generations of students will learn not just that interstellar objects exist, but that they defy expectations in ways that are still unexplained. For educators, this presents both a challenge and an opportunity: how to teach scientific knowledge while acknowledging the vastness of what remains unknown. The photograph could well become a case study in humility, teaching young scientists that mystery is not a barrier to knowledge, but the very soil in which curiosity grows. The technological ramifications of capturing such an image also deserve attention. Astronomy has long depended on incremental advances in imaging capability, from early photographic plates to digital sensors to space-based telescopes. The ability to resolve 3I/Atlas with such clarity speaks to a maturation of coordinated global infrastructure. The telescopes that contributed to the image relied on adaptive optics, atmospheric modeling, and precise timing to freeze frame a fast-moving interstellar traveler. This represents not just a triumph of technology, but also a proof of concept. Humanity can mobilize quickly to seize fleeting opportunities. With each success, we edge closer to the capacity to launch missions to objects like 3I/Atlas before they vanish back into the interstellar void. One cannot overlook the sociological dimension of the image's release. In an age where public attention is fragmented across countless sources of information, it is remarkable that a single astronomical photograph has managed to capture global imagination. Images of 3I/Atlas have circulated widely, not because they are polished or visually spectacular in the way nebulae or galaxies are, but because they are mysterious. People are drawn to what cannot be explained. The photograph resonates with a collective sense of curiosity, a reminder that the universe contains phenomena beyond the reach of even our most advanced models. This capacity to inspire collective wonder is as important as the scientific puzzles themselves, for it fuels support for further exploration. The image also resonates with cultural archetypes that stretch back into human history. Every civilization has myths of travelers from afar, wanderers who cross vast distances, bringing knowledge or disruption. 3I/Atlas, in its silent trajectory, becomes a modern version of that archetype, a messenger from beyond. Though it is not imbued with intention, the simple fact of its alien origin invests it with symbolic weight. The photograph captures this dual reality, a physical object and a metaphor for the unknown. Artists, writers, and thinkers are already beginning to interpret it in these terms, drawing connections between cosmic discovery and human narratives of exploration, exile, and return. On a scientific level, the image has provoked a surge of new hypotheses about interstellar chemistry. One of the most radical ideas is that the anomalies in brightness could be due to crystalline structures formed under pressures not found in our solar system. Imagine, for example, a body rich in supercooled nitrogen ices compressed into exotic crystalline lattices during its formation around a distant star. These lattices might fracture or refract light in ways never before documented. The photograph, in this interpretation, is the first indirect glimpse of exotic matter created under alien conditions. If confirmed, this would not only expand our understanding of chemistry, but also provide a tangible connection to environments billions of kilometers away. Another possibility raised by the image concerns the role of collisions in shaping interstellar debris. Many small bodies in our system bear the marks of violent impacts, but the peculiar ridges and fractured surfaces of 3I/Atlas suggest a history both similar and different. Perhaps it is the product of catastrophic fragmentation in a young system where planetary embryos collided with ferocity, ejecting shards into space. If this is the case, the photograph of 3I/Atlas is more than a snapshot. It is a fossil record of violent beginnings, a preserved remnant of planetary formation in another star system. Every groove, every asymmetry could be a scar from those distant collisions, offering us clues about planetary systems we will never visit directly. The enigmatic features revealed in the image also highlight a deeper philosophical question. What does it mean to encounter the unfamiliar? For centuries, humanity has expanded its horizons, from mapping Earth to exploring the solar system. Each step has involved extending known categories. Yet with 3I/Atlas, we may be reaching the point where known categories break down entirely. The photograph forces us to face the possibility that there are phenomena for which we have no language. It is both unsettling and exhilarating to consider that the universe may contain more forms of matter, more pathways of evolution, and more types of bodies than we can currently imagine. In this way, the image becomes not just a scientific artifact, but a philosophical challenge. The potential for follow-up studies adds another layer of significance. The image, while striking, is only one piece of a broader observational campaign. Spectroscopic analysis already underway will attempt to decode the chemical composition hinted at in the brightness patterns. Infrared observations may reveal heat signatures inconsistent with known materials, while radar data might provide rough estimates of density. Each of these methods will build upon the foundation established by the photograph, deepening the mystery while also pointing toward resolution. The release of the image is therefore not an endpoint but a catalyst, spurring an entire suite of investigations that will unfold over years. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the new 3I/Atlas image release? We want to hear from you. Thank you for watching, and see you next time.